How is hail formed?
Hail is precipitation consisting of balls of ice. Hailstones usually are made of concentric, or onion-like layers of ice alternating with partially melted and refrozen snow, structured around a tiny central core. It is formed in cumulonimbus or thunderclouds when freezing water and ice cling to small particles in the air, such as dust. The winds in the clouds blow the particles through zones of different temperatures, causing them to accumulate additional layers of ice and melting snow and to increase in size.
What is El Niño?
El Niño refers to the phenomenon that occurs when warming waters in the tropical Pacific build up around Christmas time. It is a fairly regular occurrence, every 2 to 7 years, but usually every 3 to 4 years. And with powerful ones every 10 to 15 years, and because it happens around Christmas. Spanish-speaking people called it El Niño after the Christ child. Meteorologists often refer to it as the ENSO, which is short for El Niño Southern Oscillation. The term Southern Oscillation was coined by Sir Gilbert Thomas Walker, 1868 to 1958. A British statistician and physicist who was studying the pattern of Indian monsoon seasons. The El Niño effect influences weather not only along the Pacific coasts of the Americas, but also worldwide. The consequences range from colder than normal temperatures in the central and eastern United States to strong storms in Africa, Australia, and the coast of California. Flooding in Europe, and declines in fish populations in South America. Climatologists increasingly believe that strong El Niños increase droughts in Africa and may be accelerating desertification there. A moderate El Niño effect was in action during the years 2006 through 2008.
Who showed that air pressure decreases as altitude increases?
French physicist and mathematician Blaise Pascal, 1623 to 1662, was inspired by fellow physicist Evangelista Torricelli, 1608 to 1647. To test the idea that the air in the atmosphere is much like seawater in an ocean. Since pressure in an ocean or lake increases as one descends into the depths, Pascal hypothesized that air pressure in a valley would be higher than on top of a mountain. To test the idea, in 1646 he asked his brother-in-law, Florine Perrier, 1605 to 1672, to use a barometer, a new invention at the time, and measure the pressure both at the top of the French volcanic peak Puy de Dôme and in the village of Clermont-Ferrand in Auvergne. The difference in elevation between the two is about 3,900 feet, 1,200 meters. Taking along witnesses to verify his readings, Perrier found that the air pressure at Clermont-Ferrand was 28 inches of mercury, and at the top of Puy-de-Dôme it was only 24.6 inches. A monument to Pascal was later erected in Clermont-Ferrand to honor this achievement. And there is also a meteorological observatory atop Puy-de-Dôme.
Is there a connection between global warming and geology?
Yes, there is an indirect connection between global warming and geology. Because changes in one part of the Earth's complex systems affect other parts. In particular, a change in the global atmosphere and biosphere can affect the rock cycle. A rise in sea level can change the expanse of glacial ice, change positions of deserts, and cause ocean waters to inundate coastlines, all of which would change rates and types of weathering taking place on our planet. Another important connection involves dissolved carbon dioxide in the oceans and surface water. Undoubtedly, the gas is taken up by organisms. But it also precipitates out of the ocean and surface waters to form certain sedimentary rocks. Carbon dioxide then returns to the system from a multitude of places, including the dissolution of carbonate minerals in rocks and shells, weathering of carbonate minerals, volcanic eruptions, or hot springs. Reactions with the atmosphere, respiration of organisms, and through streams and groundwater. Most scientists agree that a major change in the amount of carbon dioxide in or out of the environment can affect us all. Not only would humans and other living organisms be affected, but also the natural cycles connected to the world's geology. Still another geologic global warming connection may be found in the weather and climate. If global warming continues, more powerful and intense weather systems may develop. Such events as super hurricanes would cause a great deal of erosion along coastlines. Not to mention deluging countless rivers and creeks inland. In terms of climate change, variations in vegetation patterns could contribute to more erosion in various areas. Glacial, polar, and sea ice would change drastically, altering the amount of radiation reflected back into space, thus enhancing the warming effect. And changes in the hydrologic cycle would alter stream flow and groundwater levels.
What is an anticyclone?
Rather than having a low-pressure mass surrounded by swirling air, an anticyclone is an air mass centered around a high-pressure area with air rotating around it in a clockwise manner. In the northern hemisphere, and counterclockwise south of the equator. As with a cyclone, in an anticyclone air rotates faster the greater the difference between the air pressure at the center compared to the surrounding air.
What is a blizzard?
According to the U.S. National Weather Service, A winter storm is considered a blizzard when wind speeds reach 35 miles. 56 kilometers per hour, and there is poor visibility of less than 1/4 of a mile, 400 meters. Snow does not need to be falling at the time, but blowing and drifting should occur with drifts exceeding 10 inches, 25 centimeters, deep.
What is the Kelvin temperature scale?
The Kelvin scale is typically used in laboratories dealing with extremely cold temperatures. 0 degrees Kelvin indicates absolute zero, which is the point at which molecular motion stops. The scale is named after the first Baron Kelvin, William Thomson, 1824 to 1907, who was a British engineer and physicist. Thomson developed the absolute thermometric scale, which used degrees Celsius as its increments and had absolute zero being -273 degrees Celsius. The actual figure has now been determined at -273.15 degrees Celsius. Such extremes are rarely needed in meteorological studies, however.
Which of America's founding fathers were fascinated by meteorology?
Among his many other interests, ranging from agriculture to architecture, law, and politics, Thomas Jefferson, 1743 to 1826, was also fascinated by the weather. Jefferson was offended by the French naturalist Georges Louis Leclerc de Buffon's 1707 to 1788, assertion that Americans were negatively impacted by their climate, making them somehow inferior to Europeans. To prove him wrong, Jefferson and his friend and fellow founding father, James Madison, 1751 to 1836, decided to study the weather in earnest. Jefferson made daily observations from his Virginia home at Monticello from 1772 to 1778, and Madison followed his lead from 1784 to 1802. While it might seem painfully obvious today, it was Madison who broke with English logic that said temperature readings should be done indoors. He took the unheard of step of placing his thermometer outside. Today, universities are using Madison's measurements of temperature and precipitation for comparative studies on climate change.
What are Aitken nuclei?
The discovery that the air is full of tiny particles around which water droplets may condense to create clouds was made by Scottish physicist John Aitken, 1839 to 1919. We usually just call them nuclei today, but, more formally, these particles are called Aitken nuclei.
How do I know if meteorology is for me?
Choosing a career to pursue is one of the toughest choices anyone has to make. Unlike generations past, though, most Americans do not remain in their first career choice forever. And many change careers 3 or more times over their working lives. This is one reason why meteorology is actually a good choice. Because it can be applied to a wide variety of specialties. There are some questions you can ask yourself before you decide to pursue meteorology. 1.
What is dew?
Dew is water vapor that has condensed onto cool surfaces. Usually, this happens overnight as air temperatures cool. And then the dew evaporates as the day progresses.
How fast does the seafloor spread?
Today, the rates of seafloor spreading vary from about 1 inch, 2.54 centimeters per year in the mid-Atlantic ridge area to about 6 inches, 15 centimeters, in the mid-Pacific Ocean. Scientists believe seafloor spreading rates have varied over time. For example, during the Cretaceous period, between 146 to 65 million years ago, seafloor spreading was extremely rapid. Some researchers believe this quick movement of the lithospheric plates may have also contributed to the demise of the dinosaurs. As the continents changed places over time, so did the climate. In addition, more plate movements might have meant more volcanic activity, releasing dust, ash, and gases into the upper atmosphere and contributing to more climate variation. This change in climate and vegetation may have caused several species of dinosaurs to die out or become diseased, contributing to the dinosaurs' extinction.
How do I know if meteorology is for me?
Choosing a career to pursue is one of the toughest choices anyone has to make. Unlike generations past, though, most Americans do not remain in their first career choice forever. And many change careers 3 or more times over their working lives. This is one reason why meteorology is actually a good choice. Because it can be applied to a wide variety of specialties. There are some questions you can ask yourself before you decide to pursue meteorology. 1.
How fast does lightning travel?
The stroke channel of a lightning bolt is very narrow, perhaps as little as half an inch, 1.25 centimeters. It is surrounded by a corona envelope or a glowing discharge that can be as wide as 10 to 20 feet, 3 to 6 meters, in diameter.
What was the Great Exhibition of 1851?
Held from May 1 through 15, 1851, in London, England, the Great Exhibition of the Works of Industry of all nations was the first of what would become the World's Fair international exhibits. It was also called the Crystal Palace exhibit, because of the building in which it was held in Hyde Park. Among the many exhibits, the first weather map was displayed there, as well as the tempest prognosticator, a leech barometer invented by George Merriweather.
How much water is there on Earth?
Including all the world's oceans, lakes, rivers, as well as all the water contained in the Earth's soils, in the atmosphere, and in icebergs and other frozen forms. Scientists estimate that there is 3.7 x 1014 gallons, 1.4 x 1015 liters, of water on the planet.
What is the storm of the century?
Over the years, a number of storms have been called storms of the century. The 20th century experienced several storm events that could certainly qualify, or at least be nominated, for this honor. A huge blizzard struck the Midwest from January 10 to 11, 1975, that included snowfalls in Nebraska reaching 19 inches, 48 centimeters, deep, wind chills of -80 degrees Fahrenheit, -62 degrees Celsius, in the Dakotas, and wind bursts of 90 miles, 145 kilometers, per hour in Iowa. 80 lives were lost as a result of this storm. Another candidate for the title arrived on stage in 1993, when a blizzard struck the American East Coast, killing 318 people, including 48 at sea. 50% of the American population was affected in some way by the storm. The storm reached from Maine to Florida, where half a foot of snow even fell in the Florida Panhandle. And even Daytona Beach saw freezing temperatures. Winds near Key West raged at up to 109 miles, 175 kilometers, per hour. Meanwhile, Mount LeConte, Tennessee, saw 56 inches, 142 centimeters, of snow. And in Syracuse, New York, there was 43 inches, 109 centimeters, of the white stuff. The 1993 storm ranged far beyond U.S. borders, however, extending north to Canada and south all the way to Central America. At its peak, it reached the strength of a Category 3 hurricane, and by the time it was over it had dumped 44 million acre-feet. About 14.3 trillion gallons, or 54.3 trillion liters, of water onto the ground. Add to this several killer tornadoes, and perhaps the 1993 storm wins the 20th century's title as Storm of the Century.
How do meteorologists classify thunderstorms?
There are several classifications of thunderstorms, single cell the smallest type of storm system. Single cell storms form from a convective loop of warm up drafts and cool down drafts. They usually form the weakest and briefest rainstorms. Multi-cell A storm system formed from 2 or more storm cells. Supercell the largest and most dangerous type of storm system, and one which is often associated with tornadoes. Supercells develop in massive cumulonimbus storm clouds and are characterized by nearly vertical, unsuppressed updrafts and precipitation falling at a nearly horizontal angle. Because the air currents are not suppressed, they tend to continue building in strength for hours. Squall line a line of cumulonimbus storm clouds reaching up to 600 miles, 965 kilometers, long.
What were the major glacial ice ages over time?
Evidence from the geologic record shows that ice ages have occurred relatively few times in Earth's history, with the first known large-scale ice age taking place approximately 2.3 billion years ago. In the last about 670 million years, ice ages have occurred less than 1% of the time. Geologists believe there have been 5 major ice ages over geologic time. The following lists the occurrences: 1.7 to 2.3 billion years ago, Huronian era, Precambrian. 850 million years ago, Cryogenian period, 670 million years ago, Proterozoic era, Precambrian. 420 million years ago, Paleozoic era, between the Ordovician and Silurian periods. 290 million years ago, Paleozoic era, between late Carboniferous and early Permian periods, 1 million years ago, Cenozoic era, Quaternary period, Pleistocene epoch.
What is a comet?
Comets are basically snowy dirt balls or dirty snowballs, clumpy collections of rocky material, dust, and frozen water, methane, and ammonia that move through the solar system in long, highly elliptical orbits around the Sun. When they are far away from the Sun, comets are simple, solid bodies, but when they get closer to the Sun, they warm up, causing the ice in the comet's outer surface to vaporize. This creates a cloudy coma that forms around the solid part of the comet, called the nucleus. The loosened comet vapor forms long tails that can grow to millions of miles in length.
What is transportation forecasting?
Most people are probably familiar with this specialty in forecasting, which helps warn car drivers and truckers that road conditions could be hazardous. It also helps prepare local governments to clear streets and freeways. Spray road salt or sand, and have law enforcement and emergency personnel ready for emergencies. On the business level, weather forecasts can warn shipping companies. For instance, not to ship perishable products in unrefrigerated or unheated trucks. Shipments by rail also need to be ready for unfavorable weather conditions. Some larger companies rely on private forecasting firms to provide them with timely advisories.
What should I do in the event of a flood?
If a flood is expected, turn on your battery-powered radio and listen for information about when and where to evacuate. If a flood or flash flood is coming toward you, move quickly to a higher elevation, but don't ever try to outrun a flood. Also, don't drive through standing water, as it can quickly rise and stall your vehicle, possibly trapping you among swift water.
How high would the oceans rise if all the ice sheets melted?
It is estimated that if all the ice sheets melted, including the polar ice caps, ice on Greenland and Iceland, and all the glaciers on the planet, the average worldwide sea level would rise by about 250 feet, 76 meters. Such a rise would decimate almost all coastal cities, shrink the living space on all the continents, cause massive climate fluctuations, and change our lives forever.
At what temperature does seawater freeze?
While the amount of salt and other minerals and impurities in seawater makes a difference. In general, seawater freezes at about 28 degrees Fahrenheit minus 2.2 degrees Celsius.
How were cosmic rays shown to be charged particles?
In 1925, American physicist Robert A. Millikan, 1868 to 1953, lowered an electroscope deep into a lake and detected the same kind of powerful radiation that Victor Franz Hess had found in his balloon experiments. He was the first to call this radiation cosmic rays, but he did not know what they were made of. In 1932, the American physicist Arthur Holly Compton, 1892 to 1962, measured cosmic ray radiation at many points on Earth's surface and found that it was more intense at higher latitudes, toward the North and South poles, than at lower latitudes, toward the equator. He concluded that Earth's magnetic field was affecting the cosmic rays, deflecting them away from the equator and toward Earth's magnetic field. Since electromagnetism was now shown to affect the rays, it was clear that cosmic rays had to be electrically charged particles.
What is the difference between a cyclone and a typhoon?
The words cyclone and typhoon are simply other words for hurricane. When hurricanes occur west of the international dateline in the Northwest Pacific Ocean, they are referred to as typhoons. And when they occur in the Indian Ocean and near Australia, they are called cyclones.
What is indoor humidity?
Because we now live in homes with environments controlled by air conditioning, furnaces, and fans, the humidity inside is often very different from what the weather is like outside. For instance, in the winter many homes are very dry inside, which increases static electricity and causes uncomfortably dry skin. Overly humid air within a home can lead to the development of mold and mildew, some of which can be a risk to your health. Also, air that is too dry or too moist can cause structural damage to a house. Overly moist wood, too, encourages pests such as termites to chew wooden supports and flooring.
What are some other significant air pollutants?
Oxides of nitrogen, including nitrogen monoxide, NO, nitrogen dioxide, NO2, and nitrous oxide, N2O, are also generated by factory and car emissions. These gases are not directly harmful to people, but they contribute to ozone depletion.
What is Earth's magnetic field?
Electromagnetic force permeates our planet. In essence, Earth itself acts like a giant spherical magnet. This is caused primarily by the motion of electrical currents within Earth, probably through the liquid metallic part of Earth's core. Combined with Earth's rotation, the core acts like an electric dynamo or generator, creating a magnetic field. Earth's magnetic field extends thousands of miles outward into space. Magnetic field lines, carrying and projecting electromagnetic force, anchor at Earth's magnetic poles, north and south, and bulge outward, usually in large loops. Occasionally, they stream outward into space. The magnetic north and magnetic south poles of Earth's magnetic field are very close to the geographical north and south poles, which mark the axis of Earth's rotation. Be careful. By the way, there are two ways to define Earth's magnetic poles. The magnetic North Pole is on an island in Canada, but the geomagnetic North Pole is actually on Greenland. And the geographic North Pole is on an ice shelf floating on the ocean, hundreds of miles from any land.
Is it possible to forecast space weather?
by understanding past solar activity patterns and comparing them to current observations. Astronomers can make some rough predictions about possible upcoming geomagnetic storms. This type of forecasting is important, so that warnings may be issued concerning dangers to orbiting satellites and other space missions, as well as the risks posed to electric power grids on Earth.
Do other planets in our solar system experience weather?
Many planets and even moons in our solar system have atmospheres and, therefore, weather. The gas giants Jupiter, Saturn, Uranus, and Neptune all have very thick atmospheres which include storms and even lightning. Lightning has been observed on Jupiter, Saturn, Io, and Titan, and is speculated to exist on Venus. Jupiter, of course, is famous for the huge swirling Great Red Spot, which is a windstorm 8,500 miles, 14,000 kilometers, wide and 16,000 miles, 26,000 kilometers long. That astronomers estimate has been ongoing for at least 400 years. Saturn, too, has a thick atmosphere topped by crystallized ammonia clouds. It also has a great white spot. But this storm lasts for about a month and then fades, recurring at intervals. Uranus has a distinctive, blue-green atmosphere made mostly of hydrogen, 83%, and helium, 15%. Neptune also has a blue color, which is why it is named after the Roman god of the sea, with a hydrogen-helium-methane atmosphere. Below this upper atmosphere, astronomers believe Neptune has a lower atmosphere made of ammonia, crystallized methane, and ionized water. Even deeper may be a layer of hydrogen sulfide. The winds on all of these planets are believed to be very powerful. Neptune, for instance, has winds reaching 700 miles, 1,100 kilometers, per hour. The planet has a great dark spot, that is an ongoing storm about the size of Earth's moon, and a smaller, white storm that has the whimsical name of Scooter. Not counting Earth, the inner planets Mars, Venus, and Mercury all have atmospheres. The atmosphere on Mars is very thin, and it has an air pressure about 1% that of Earth's. Theories abound as to why Mars lost its atmosphere, ranging from giant asteroids smashing into the planet and ripping away its air, to the lack of plate tectonics providing sufficient heat, to the idea that the planet somehow lost its magnetosphere. Without much atmosphere, Mars does not have much weather. Mercury, similarly, has virtually no atmosphere and is essentially a big rock in space. Venus is far more interesting than either Mars or Mercury, in terms of atmosphere. It is a planet with an atmosphere too rich in carbon dioxide, and consequently it experiences a runaway greenhouse effect that heats the surface to 900 degrees Fahrenheit. 500 degrees Celsius, which is hot enough to melt metals like lead, tin, and zinc. Poor Pluto, which has been downgraded in status from planet to planetoid, has a thin atmosphere containing nitrogen, methane, and carbon monoxide. Several moons in our solar system also have atmospheres. Of these, Saturn's Titan is perhaps the most interesting. Its dense atmosphere, 50% denser than Earth's, contains 98.4% nitrogen and 1.6% methane. Astronomers believe that Titan has lakes and seas composed of liquid methane and nitrogen, and that it experiences rain showers made of methane. A smoggy, orange haze made of hydrocarbons envelops the atmosphere. Some other moons have thin atmospheres, such as Neptune's Triton, and Ganymede, which is another moon circling Jupiter, is believed to have a water ocean beneath a layer of ice.
If a parhelion is a sun dog, what is an anthelion?
Also caused by hexagonal ice crystals in the air, an anthelion is like a parhelion, except that it is seen at the azimuth opposite the Sun.
Does the Sun have an atmosphere?
Yes, in a manner of speaking. Since the Sun is made primarily out of hydrogen, 73%, and helium, 25%, in a plasma state, there's no visible solid surface to distinguish a dividing line between the Sun's body and its atmosphere. The surface of the Sun is a layer called the photosphere that is about 300 miles, 480 kilometers, thick and has an average temperature of about 10,000 degrees Fahrenheit 5,500 degrees Celsius. Above that is a second layer, called the chromosphere, that is thousands of miles thick, and is somewhat cooler 7,800 degree F, 4,300 degrees Celsius. Above that is the Sun's corona, which is where temperatures kick into high gear. Temperatures in the corona average about 1.8 million degree F, 1 million degree C.
What is the Space Weather Prediction Center, SWPC?
Part of the National Weather Service, the SWPC monitors solar and geophysical events that can affect communications, power grids, artificial satellites, and navigational systems.
What is a flash flood?
Floods can happen relatively gradually, such as when water slowly rises over the banks of a river or lake. Or suddenly, such as when a dam or levee is damaged. When a flood happens quickly, it's called a flash flood.
What are some other types of anemometers?
Besides the rotating cup anemometer, there is the sonic anemometer, swinging plate, or pressure plate. Anemometer, pressure tube anemometer, bridled, or windmill, anemometer, and the aerovane. Weather stations often use sonic anemometers, which calculate both wind speed and direction. 4 ultrasound transducers are set up in a circle, evenly spaced apart, in 2 pairs placed across from each other. A transducer will send out an ultrasonic signal to the one directly across from it. Winds blowing across this path will cause the signal to travel faster, slower, or change direction, thus indicating wind conditions. Pressure plate and pressure tube anemometers work by the fact that wind blowing against a plate or through a tube will exert a measurable pressure. Aerovanes and windmill anemometers can measure both speed and direction. As the blades on these devices spin, it is possible to calculate wind speed, and both will turn into the oncoming wind, which indicates direction.
What is Buys-Ballott's law?
Dutch meteorologist and chemist Christoph Hendrik Diederik Buys-Ballot, 1817 to 1890, was a pioneer in meteorology, especially when it came to explaining how air flows in large weather systems. The law that bears his name refers to the fact that when you stand with your back to the wind, the air pressure will be lower on your left than on your right in the northern hemisphere. And the opposite is true if you are standing in the southern hemisphere. This phenomenon, which actually only proves to be true during well-organized weather systems, was also discovered by American climatologist William Ferrel, 1817 to 1891. Ferrel actually formulated this theory a few months before Buys-Ballot. The Dutchman graciously acknowledged that the credit deserved to go to Ferrel. But the law had already been denoted Buys-Ballot's law, and the name stuck. Trade winds are very consistent winds blowing through the tropics, between 30 degrees south and 30 degrees north latitudes. At about 11 to 14 miles, 18 to 22 kilometers per hour, sometimes for days on end. In the northern hemisphere they blow toward the equator from the northeast, and south of the equator they blow in from the southeast. While the term trade winds leads most people to think they got their names from the days when large sailing ships depended on them for shipping routes. The word trade actually has a German origin and means track or path.
What is the dew point?
The dew point is the temperature at which air is full of moisture and cannot store any more. When the relative humidity is 100%, the dew point is either the same as or lower than the air temperature. If a fine film of air contacts a surface and is chilled to below the dew point, then actual dew is formed. This is why dew often forms at night or early morning, as the temperature of the air falls. The amount of water vapor the air can hold also decreases. Excess water vapor then condenses as very small drops on whatever it touches. Fog and clouds develop when sizable volumes of air are cooled to temperatures below the dew point.
What are spiral bands?
The clouds arranged in curving bands that form the outside of a hurricane, rather like those in a spiral galaxy, are called spiral bands. They can extend for several hundred miles beyond the eye of the hurricane.
What are the dog days of summer?
The dog days of summer comprise a period of extremely hot, humid, and sultry weather that traditionally occurs in the northern hemisphere in July and August. Traditionally, the days run from July 3rd through August 11th. The term comes from the dog star, Sirius, in the constellation Canis Major. At this time of year, Sirius, the brightest visible star in the sky, rises in the east at the same time as the sun. Ancient Egyptians believed that the heat of this brilliant star added to the sun's heat to create hotter weather. Sirius was blamed for everything from the withering droughts to sickness to the discomfort that occurred during this time.
What is radar?
Radar is an acronym for radio detection and ranging, and it uses radio waves to detect objects in the atmosphere. It was first devised in 1904 by the German inventor Christian Hülsmeyer, 1881 to 1957. Who called his radar detector a telemobiloscope and patented the device in 1906. The original purpose of his invention was for ships to be able to detect each other so that in poor weather conditions, e.g., heavy fog, they would not run into each other. Sadly, this brilliant invention did not catch on at the time. If it had, some speculate that the 1912 Titanic disaster could have been avoided. Another concept that Hülsmeyer came up with was the remote control. He believed, correctly, that radio waves could be used to turn mechanical devices on and off. Again, people ignored the concept and he never got the credit he deserved.
How much pollen is in our air?
Pollen from plants just within American borders produce about 2 billion pounds of particulates every year, or about 7 pounds per person.
How much do meteorologists earn?
You should never pick a career solely based on its earning potential. Pick something you love, and then go from there. That being said, meteorologists make very good wages indeed. As of 2009, average salaries ranged from $70,000 to $108,000 annually. On the low end, the salary for a degree-holding meteorologist was about $53,000, at the upper end. A meteorologist in a specialized field with a PhD can easily make $125,000 a year.
As for the future, who knows?
Hurricanes seem to be increasing in size and number in the 21st century. And it is possible that one could travel across, say, northern Mexico and then reach southern California.
What measurements do weather satellites provide us?
Early weather satellites transmitted images of clouds and could also take infrared IR readings, which allowed for weather monitoring both day and night. With IR sensors, satellites can detect temperature readings, which can also indicate cloud elevation. Modern satellites are capable of many other observations, as well. Detailed images of not only clouds, but also land and sea surfaces and temperatures. Provide scientists with information about fog, snow, rain, ocean currents, haze, air pollution, ozone levels, soil moisture levels, airborne dust, and even volcano and forest fire activity. Satellites are also used to take surveys of agricultural activities and vegetation growth.
What is the doctor?
This is an affectionate term, used in places such as the Caribbean, referring to the cool, refreshing sea breezes that make a hot day more bearable.
What has the National Climatic Data Center reported about average temperatures in 2008?
According to the NCDC, the average temperatures for the contiguous 48 U.S. states was 0.3 degrees Fahrenheit, 0.14 degrees Celsius cooler than the average measured from 1900 to 2000.
Who is considered one of the most important pioneers in the study of climate change?
English meteorologist and climatologist Hubert Horace Lamb, 1913 to 1997. Who founded the Climatic Research Unit at the University of East Anglia in 1971. Is considered by many to be the greatest climatologist of the 20th century. He began his career as a weather forecaster for the Irish Meteorological Office and later was with the British Meteorological Office. While there, he participated in a Norwegian whaling expedition in Antarctica from 1946 to 1947. It was during this time in Antarctica that he began to study how the world's climate must have changed. And he pursued this subject after joining the climatology division of Britain's Meteorological Office in 1954. Using records there, he researched and published papers and books about how Great Britain's climate had changed noticeably since the middle of the 19th century.
On where does the word gas come from?
The person who is credited with coming up with the word gas is Flemish physician Jan Baptiste van Helmont, 1577 to 1644. His experiments with gas and volume taught him that gases always take up all the space within a container, they do not leave a vacuum. Thus, he surmised that substances in a gaseous state exist in a chaotic form. The Flemish pronunciation for chaos sounds like gas, and thus the word was born. Earth, this is accomplished by plants and algae that conduct photosynthesis, removing carbon dioxide from the atmosphere and adding oxygen into it. It was during the Carboniferous period about 300 million years ago that plant growth dramatically changed the atmosphere, increasing the amount of oxygen to 35%. Today, the oxygen content is not quite as rich, 21%.
Can people's moods be affected by sunlight?
It is well known that, during the winter, people living in the northern hemisphere tend to experience more depression and listlessness, sometimes called seasonal affective disorder, SAD. This syndrome may be caused by chemical changes in the brain during extended periods of darkness. In addition, the human body needs at least a few minutes of sunlight a day to generate vitamin D. Vitamin D deficiency is a chronic problem in many northern states in America, where it can lead to feelings of depression and a lack of energy and even libido.
What is a multiple vortex tornado?
Sometimes a central tornado can be surrounded by smaller tornadoes called subvortices or suction vortices. There can be as many as 7 subvortices surrounding the central tornado, though 2 to 5 is more common. Interestingly, these smaller tornadoes tend to be more intense, with winds spinning at about 100 miles. 160 kilometers per hour or more faster than the central vortex.
What is a snow roller?
People aren't the only ones who enjoy building snowmen. Sometimes, nature gets into the game as well. In windy, wintry conditions, breezes have been known to start small collections of snowflakes rolling. As they roll, snow accumulates and the snowball gets bigger and bigger. Such snow rollers have been known to grow to diameters of several feet.
What is inadvertent weather modification?
This, of course, means accidentally changing the weather, usually for the worse. Humanity has been very good at that, especially as a result of activities that lead to deforestation and pollution. It is now common knowledge that chemicals from cars and industry are destroying the ozone. And particulates from emissions also have an effect on precipitation. Cutting down forests in favor of croplands, urban construction, golf courses, and so on causes more sunlight to be reflected back into the atmosphere but can also cause urban heat islands. Animal agriculture can increase methane gas in the atmosphere. And irrigation of plants alters water distribution. All of these activities and more have noticeably changed natural weather patterns and the climate without humans intending to do so.
What happened in the 1940s and 1950s that gave hope to the science of numerical weather prediction?
Hungarian-American mathematician John von Neumann, 1903 to 1957, devised a forerunner of the modern computer that could make the rapid calculations needed to predict the weather using the numerical forecasting method. Next, Princeton University meteorologist Jules Charny, 1917 to 1981. Having studied Richardson's earlier failure, wrote revised formulas in 1946 that could be used for weather prediction with the help of von Neumann's computer. With this background foundation in place, in 1950 the first successful weather forecast using the numerical method was completed in April, 1950, by the ENIAC computer at Maryland's Aberdeen Proving Ground. An ongoing weather forecast service was then begun in 1955, using an IBM computer funded by the National Weather Service, and the U.S. Navy and Air Force.
How hard is it to become a meteorologist who is a radio or television broadcaster?
If your goal is to specifically become a television weatherman or weatherwoman, then, ideally, you need to combine training in meteorology with education in communications and/or the broadcast arts. You should be comfortable appearing on camera. And it helps if you have completed an internship in broadcasting while in school. As with anyone who wishes to pursue a television or radio career, you will have to sell yourself as an appealing on-air personality. Prepare professional demo tapes of yourself doing a broadcast and send these to news directors at the stations for which you wish to work. You should prepare yourself to start at the bottom of the career ladder. Which means working shifts in the very early morning or very late evening hours. As well as working for low pay in a town or city that has a small market. Don't expect to work right away for a big network in New York City or Los Angeles. It could be years before you manage to get a job in a big market. And in the meantime you will likely move frequently while you search for better and better opportunities. Today's media world is especially challenging, as stations and newspapers across the United States are cutting their budgets and centralizing operations. Weather broadcasting is probably the hardest specialty to get into these days. And many other fields within meteorology offer better opportunities.
What is a meteor?
A meteor is a particle from outer space that enters Earth's atmosphere, but does not land on Earth. Instead, the particle burns up in the atmosphere, leaving a short-lived, glowing trail that traces part of its path through the sky. Like meteorites, meteors can range from the size of a grain of sand on up, most of the time, though. A meteor larger than about the size of a baseball will reach Earth, in which case we call it a meteorite.
What is the heat index?
The heat index is a measurement of what hot weather feels like to the average person for various temperatures and relative humidities. Heat exhaustion and sunstroke are inclined to happen when the heat index reaches 105 degrees Fahrenheit 40 degrees Celsius. The reason why it feels hotter to people when it is more humid is that the body cools itself by perspiring. Beads of perspiration help cool the skin as they evaporate. But when the air is too humid to allow for this evaporation, this natural cooling system no longer works well. The danger point for humans can occur when the heat index is between 90 degrees Fahrenheit 32 degrees Celsius and 104 degrees Fahrenheit 40 degrees Celsius. And when the heat index reaches above these temperatures, weather conditions become very dangerous indeed. At this extreme, heat exhaustion, heat stroke, or sunstroke may occur quickly. Especially during physical activity, and it is very important to stay in the shade and remain hydrated. The chart below provides the heat index for some temperatures and relative humidities.
How many Category 5 hurricanes have there been since 1920?
The Saffir-Simpson scale was not invented until 1971, however. Reliable records on hurricane wind speeds and storm surges have been kept since the 1920s. According to such data, there have been 31 Category 5 hurricanes in the Atlantic since 1928. 8 of those have occurred since 2003, 4 in 2005 alone, which is one piece of evidence. Some climatologists point to when talking about global warming and its effects on tropical storm intensity. Of all those hurricanes, only 4 have actually made landfall on U.S. territory. Others have struck Central America or islands in the Caribbean, or they have weakened to Category 4 or below before reaching Puerto Rico or the Gulf Coast or Atlantic seaboard. Below is a chronological list of Category 5 hurricanes.
What standard unit of measurement is used to indicate wind speed?
In most forecasts in the United States, wind speed is described in miles per hour. Outside this country, it would be expressed in kilometers per hour. Most other scientists also prefer to use the metric system. However, the Federal Aviation Administration, National Weather Service, and other groups that work with air and ocean travel will use knots. 1 knot equals 1.15 miles per hour, or 1.85 kilometers per hour. Internationally, wind is also commonly measured in meters per hour. For vertical wind speeds, meteorologists use microbars per second, which indicates pressure change with altitude over time, or centimeters per second.
What is a pyranometer?
A pyranometer, also called a solarimeter, is an instrument that measures the amount of sunshine reaching the ground. Pyranometer comes from the Greek words pyr, meaning fire, and ano, meaning sky. The instruments record the amount of sunlight in terms of watts per square meter. And they calculate this in one of 2 ways. A less accurate method used in cheaper models of pyranometers detects light using small silicon-based photodetectors. This method is not considered to be ideal because such photodetectors do not capture the full spectrum of sunlight very well. The other type of pyranometer uses a thermopile, which is a collection of highly sensitive thermocouples that detect temperature changes across junctions. Pyranometers can be used to evaluate weather conditions and, when readings are taken over extended periods of time, changes in climate.
What unusual floating objects have been used to help chart currents in the oceans?
In a rather humorous example of kismet, oceanographers have been taking advantage of a 1990 accident in which a Korean cargo ship accidentally dumped 80,000 Nike shoes into the ocean. Since then, whenever these shoes have been found floating in the Pacific Ocean and elsewhere, oceanographers have taken note, tracking where the accident originally occurred and comparing it with the location where the shoes were found. In this way, they were able to gather additional information about currents. It wasn't long before another accident created a new opportunity for studying the currents. In January 1992, a ship hauling toys lost part of its cargo in a storm. Nearly 30,000 rubber ducks, frogs, turtles, and beavers fell into the ocean. As with the athletic shoes, these toys, as they washed up on various shorelines, served as excellent indicators of the course taken by ocean currents.
What is aviation forecasting?
Aviation forecasting is a critical support service for the airline industry. Aviation forecasters warn pilots and airline management about potentially hazardous weather conditions that could lead to wind shear, wing icing, severe turbulence, strong winds, thunderstorms, or other dangers. While passengers might be frustrated by the delays in air travel that result from these warnings, aviation forecasting probably saves hundreds, even thousands, of lives every year. In addition to the worst-case scenarios that might occur if pilots were not warned of dangerous weather, aviation forecasters can also advise on wind conditions that can help save fuel by not having planes fly into head-on winds. When the cost of airline fuel rises, this has the potential of saving airlines billions of dollars.
When did radar finally catch on, and who gets the credit?
In 1935, over 3 decades after Hullsmeyer first proposed the idea, radar technology came into its own through the work of British scientist Robert Watson Watt, 1892 to 1973, along with H. E. Wimperis, 1876 to 1960, Henry Tizard, 1885 to 1959, and A. F. Wilkins, working for the British government. Watson Watt was given the assignment of investigating whether Germany's Adolf Hitler could carry out a threat of creating a weapon using radio waves. Watson Watt knew this was an impossibility, but he saw another potential use. Using shortwave radio transmitters from the British Broadcasting Corporation, he and his colleagues created the first practical radar technology. Radar was used to detect attacking German airplanes during World War II, and was credited with swaying the 1940 Battle of Britain in England's favor.